All right, let's look at the homework 11.2, problem number 6. All right, so we have a telescoping series here, and we want to determine if it's convergent or divergent. And if it's convergent, we'd like to find its sum. All right, so let's do that. All right, so we have to do a partial fraction decomposition here. So I'm going to write this guy as 6 over. Right, factor out the denominator, we get n minus 1 times n plus 1. Right, so this is going to be equal to, right, so we can split this into some constant a over n minus 1 plus b over n plus 1. Right, so we're going to put these guys back together. So n minus 1 times n plus 1. Right, then we would have to multiply a by n plus 1 and multiply b by n minus 1. Right, so since the denominators already match, so we have to match the numerators. Right, so easiest way to find a and b is just set, so in order to find a, I'm going to get rid of b, so I'm going to plug in n equals 1. Right, then you have a 1 plus 1a, so you have a 2a here, and that's 0, and it has to be equal to 6. So we can divide through by 2 to get a value, which is 3. Right, then in order to find b, we can set n equals negative 1. Right, that way this is 0, so we have a negative 1 minus 1, so it's going to be negative 2b, and still the other side is 6. So we can divide through by negative 2 to get the b is equal to negative 3. Right, then we can rewrite this guy as, so it's a summation. Right, n starts from 3 to infinity. Right, then we have 3 over n minus 1 minus 3 over n plus 1. Right, so let's find the partial sum. So Sn is going to be, right, n starts from 3, so we're going to start with 3, so you have 3 over, right, 3 minus 1 would be 2, minus 3 plus 1 is 4, so 3/4. Right, next one is n equals 4, so you're going to have 3 over 3 minus 3 over 5. Right, next one is going to be 3 over 4 minus 3 over 6. And the next one is 3 over 5 minus 3 over 7. Right, then this keeps on going until, right, second to last one would be 3 over n minus 2 minus 3 over n. And the last one is 3 over n minus 1 minus 3 over n plus 1. Right, so that's the partial sum, and what we want to do is try to cancel as many terms as possible. Right, so you can see that the cancellation happens here. Here's the second one in the parentheses, and skip one set of parentheses, the first one, to cancel with that. Right, so this guy, skip one and cancel that. This guy, skip 1, cancel with this guy, and this guy is going to cancel. All right, and this one is going to cancel, skip 1 and a 1 here. All right, and this one has a 1, but this one doesn't have anything here. This one doesn't either. So those guys have to stay. So you have 3 halves here, and then you have a 3/3, and then we have a negative 3 over n and a negative 3 over n plus 1. All right, so this simplifies to, all right, so you have a 3 halves and plus 1. So it's going to be 5 halves. All right, then you have minus 3 over n minus 3 over n plus 1. All right, so if you want, we can just take the limit of this partial sum, which is 5 halves minus 3 over n minus 3 over n plus 1, and as n approaches infinity. Right? This is fairly easy because these two terms, 3 over n goes to 0 because 3 divided by a big number, and for the same reason this guy goes to 0. So the sum is going to be simply 5 halves. So since the limit is convergent, it is going to be convergent, and sum is 5 halves. Right? Let's type it in. Right, so we have a convergent, and the sum is 5 halves. Right, so let's submit for testing. Okay, looks like we got both of these guys correctly. All right, that's it. I hope that this was clear.